All right, good morning, guys. Today we're going to be covering 10.2 surface areas of pyramids and cones. Our learning target is I can find and use surface area of pyramids and cones. So let's go ahead and get started. Again, as you may guess, today we are focusing on those two shapes. We have pyramids and we have cones. And the big distinguishing things about these two shapes is that both of them meet at a single point at the very top. So we'd say that they're lateral areas, the areas that aren't the base, those all meet at a single point. And that's the biggest difference between prisms and pyramids and cones, because oftentimes people will mistake a pyramid for a prism. And again, it's not because of this single point where all the triangles meet. Now, we're going to have lots of different types of pyramids. For instance, this first one is a square pyramid because the base is a square. If the base were a triangle, it'd be a triangular pyramid. If the base were a pentagonal pyramid, a rectangular pyramid, whatever shape the base is, that is in the name of the pyramid. So for instance, again, this is a square pyramid because our base is a square. So keep that in mind. That is a common mistake that people make. But again, our base can be whatever shape it would like. Now, if it runs that our base is a circle, that's the only shape that it cannot be and still be a pyramid. Because if we have a circular base, that would mean that we have a cone. And again, a cone has a circular base and meets at a point at the very top. So keep that in mind. If it's any shape besides a circle, it'd be a pyramid. And then if it does have a circular base, it would be a cone. So we have a net of a pyramid here, and I just want to go through each different variable to make sure that we're comfortable with any variable that we run across. Now, this is just a pyramid flattened out, and as we can see, it's made up of 4 triangles on all 4 sides of our base, and all 4 of those triangles meet at a single point when raised. Now, first off, P. P will be the perimeter of our base, so it's the distance around our base. Now, if it's a square, then of course I just add all the sides together. If it's a triangle, same thing, but make sure that you're keeping track of how many sides you're adding and what the length of each side is. So again, it's the distance around our base. Next up, we have L. L is our slant height. Now, keep in mind that L goes along the side of the figure. It's along the triangle. It is not the height of the pyramid, but the height of the triangle. Again, the height of the pyramid would be the altitude. And the altitude would, again, start at the same spot at the point, but it would go down and land straight in the middle of our base. Not on the side of our base, not on the edge, but right in the center. So that's the difference between slant height and height. No, they are not the same, and that is a very common mistake that people make. Slant height is the height of the triangle, not the height of the pyramid. The last variable that we have is large b. B will be the area of the base. Now again, since we have different types of pyramids, if the base is a triangle, I'd use the area of a triangle. If it's a pentagon, I'd use the area of a pentagon, so on and so forth. But again, it's the area of whichever shape we're dealing with. Now, as for our lateral area, again, the lateral area is just the area of all 4 sides that are facing outward, not including the base. So therefore, just be the area of these 4 triangles. So therefore, I can say that the area is equal to 4 times the side times the slant height, or just simplify it a bit further, lateral area will be the perimeter multiplied by the slant height times 1/2. So lateral area is equal to half of P times L. And you may be wondering, where does this come from? Well, this is just from the area of a triangle. 1/2 base times height. In this case, my base is the full length, so I'm dealing with all 4 of them at once. And then my height is just the height of the triangle, L, our slant height. So again, this is just the area of a triangle, except since we're using perimeter, it's for all 4 of them. Of course, all 4 need to have the same slant height. As for our surface area, Well, our surface area is the exact same as our lateral area, except we're also including our base. So therefore, surface area is equal to L plus B, or if I break down the L a little bit further, it'd be 1/2 of perimeter times L, again, this is just my lateral area, plus the area of my base. Now, again, make sure that you're comfortable with this because most questions will ask you to find your lateral area and then find your surface area. So if you use the second equation down here, you'll be able to find both at the same time. Let's go ahead and recap that real quick just to make sure that we all understand and are all on the same page. Again, when we're dealing with pyramids, we have a 3D perspective here, and we see that we have L. Now, I just want to make sure that we're realizing that L is on the outside, and we can see it because it intersects the edge here, the side of our triangle, or sorry, the side of our pyramid, at 90 degrees. So that would be our slant height. Actual height would go from the center and go straight towards the middle here. So it would actually intersect right here. So again, L is our slant height, P is our perimeter of the base, and big B is the area of the base. Make sure that you know where to find these on our pyramids and how to plug them in. Again, lateral area will be equal to big P times L times 1/2, where that's half because we're dealing with triangles. Meanwhile, our surface area is equal to 1/2 P times L plus B. So make sure that you're comfortable with all these. We're going to be using all of these formulas throughout. One last thing. If I'm actually given the height and I want to find L, my slant height, how could I do it? Well, if I'm given the actual height, I know that's going to intersect 90 degrees. Thus, it would create a right triangle, so I could use Pythagorean's theorem. So let's go ahead and try out a sample problem. We want to find the surface area and lateral area of the pyramid. So we're going to go ahead and start with lateral area. Lateral area is equal to 1/2 of P times L. If I look here, I have 9 on the outside. And since 9 is intersecting the triangle side here, this edge, it's not intersecting the middle of our plane, the middle of our base, it's intersecting the edge. 9 is our slant height. So 9 is equal to L. Further, if I look at our base, we have side lengths of 5 and 5, which means that we're dealing with a square base. So to start with our lateral area is equal to 1/2 of P times L. Again, we said that L is equal to 9. And then our perimeter, since it's a square, it'd just be 5 plus 5 plus 5 plus 5. That will give us 20. At this point, I can go ahead and plug in for our lateral area. I have 1/2 of 20, which is 10. 10 times 9, which is 90 units squared. So therefore, our lateral area is 90 units squared. If I want to find my surface area, I just need to add the area of my base to it. Well, my base is 5 by 5, and it's a square. So therefore, the area of my base is 25 units squared. So therefore, I am going to have 90 plus 25, which will lead me with surface area is equal to 115 units squared. All right, next up. We want to find the surface area and lateral area of the pyramid. So looking here, again, I have side lengths of 10 all the way around, so I'm dealing with a square pyramid. And I can see that I have a length of 12 here. If I look at this, 12 is starting at the very tipping point, the very top of our pyramid, and it goes straight down into the middle of our pyramid. Would that be a slant height? No. That is the altitude of the pyramid. That's our height of the pyramid. So since that's the height of our pyramid, I need to find L. And looking at this, I have a right triangle with one leg being 12, the hypotenuse being L. What would my bottom leg be? Well, since this is a right triangle, and it's going through a square, and it's going into the middle of that square, well, then this should be half the side length of my triangle. Or sorry, half the side length of my base. So if one side of my base is 10, this side of my triangle should be 5. Which means I can use Pythagorean's theorem. 5 squared plus 12 squared equals L squared. 5 squared is 25, plus 12 squared, which is 144, will leave us with 169 equals L squared. The square root of 169 will leave us with 13. So L is equal to 13. Meanwhile, if I want to find my perimeter, well, since this is a square base, all sides are 10. So therefore I have 10 plus 10 plus 10 plus 10, or 40 units. Now that I have perimeter and slant height, I can plug into my lateral area. Lateral area is equal to half our perimeter, 40, times our slant height, 13. Half of 40 is 20, and 20 times 13 will leave us with 260 units squared. In this case, it's meters squared. Now that I have my lateral area, I can go ahead and find my surface area by adding the area of my base, the square, to my lateral area. Well, looking at the base of my pyramid, since it is a square and each side length is 10, base should be 10 times 10. Well, 10 times 10 is 100 units squared, so big B is equal to 100. From there, I plug in both my lateral area, 260, and my base area, 100, into my surface area equation. Surface area is equal to lateral area plus the area of our base, bringing us to 260 plus 100, which is 360 units squared. All right, now let's go ahead and move on to cones. With cones, they have some specific things that we need to watch out for. So very similar to pyramids, the main difference with cones is that our base is a circular base. And since it's a circular base, we need to be thinking about the distance around a circle, or circumference. Further, lateral surfaces meet at a single point at the top, very similar to pyramids as well. And the last point is what's really going to change our equation for lateral area and surface area. It's what happens to our radius as we change our height. As I move up and down a cone, the height changes my radius. So the radius changes depending on what height you're at. So in this case of my cone here, we see that we have a radius down here at the very bottom, r. What's the radius of the circle? Again, we have circles all the way through. What's the radius of my circle at the very top? Would be 0. So therefore, I'm going from a radius of 0 to a radius of r, which means that my radius is an average. The average radius is what I'm looking for. So if the average radius is between r and 0, well then I can do r plus 0 divided by 2, which will give me an average radius of r over 2. Again, this is my average radius of a cone. Now, again, with lateral area, it's the distance around, so it should be fairly similar to the lateral area of a pyramid, which was P times L times 1/2. Since we're dealing with a circle here, it should be 2 pi times r, that's the circumference, times our slant height. Well, our r changes constantly. So if I plug in our changing r, the average of our r, I'd be left with our lateral area being equal to 2 pi times r over 2 times L. Well, what happens with our 2 in our denominator of 2? Well, they cancel, which leaves us with a lateral area which is equal to pi times r times L. That is the lateral area for any cone. And again, it happens because our radius changes as we move up or down our cone itself. So again, if I move up halfway, this is half my radius. If I move up all the way, my radius is 0. So again, we need to find the average radius between r and 0, which would be r over 2. So that leads us to our formula for cones. Again, for lateral area, the area would be pi times r times L. Meanwhile, our surface area is the same exact thing. Pi times r times L plus the area of our base, big B. Well, looking at our base, it's a circle. The area of a circle is pi r squared. So therefore, our surface area is equal to pi RL plus pi r squared. Again, only two variables that we need in order to solve for this surface area. We just need the radius and the slant height. Let's go ahead and try out a couple practice problems. Again, keep in mind of each of these variables, so make sure that you're comfortable with all of them. R is radius, L is slant height, and B is the area of our base, which is the area of a circle in this case. So, our first one, we want to find the height of the cone given a surface area of 36 pi centimeters squared. So looking here, I have the radius, and we want to find the actual height. We want to find the altitude. So, we are also given our surface area. Let's go ahead and plug into our surface area formula. Surface area is equal to pi RL plus pi r squared. Well, if surface area is equal to 36 pi, I can say 36 pi is equal to pi times our radius 4 times L plus pi times our radius 4 squared. At this point, I notice that both of my terms on the right side of my equation have a pi. So I'm going to go ahead and factor out a pi, which will leave me with 36 pi is equal to pi times 4L plus 16. Again, the 4L, I just brought these down. 4 squared will give me 16, and then the pi's just go outside the parentheses. I factored them out. From here, I'm going to divide both sides by pi to get rid of all my irrationals at once, and this will leave me with 36 equals 4L plus 16. At this point, it's a two-step equation, so I'm going to go ahead and subtract 16 from both sides, leaving me with 20 equals 4L. And lastly, dividing both sides by 4, I'm left with L equals 5. So, did we answer the question? Did we find the height of our cone? No. What we found is our slant height. So think, how can I find the actual height here? Well, I know that the actual height of a cone starts at the very top and goes straight down to the center of the base, which would be the center of our circle. Well, it's also going to intersect the base at 90 degrees, which would create a right triangle, meaning that we can use Pythagorean's theorem. H squared plus 4 squared equals 5 squared. 4 squared is 16, 5 squared is 25. Subtracting 16 from 25 will leave us with h squared equals 9. The square root of 9 will give us 3. So the height of our cone is equal to 3 centimeters. All right, let's try out one last problem. A company packages popcorn in plastic containers in the shape of a right cone. Each container also has a plastic circular lid. So if I look here, the cone portion, the lateral area, would be our paper. The top, our base, would be the plastic. We want to find the amount of paper needed to make each container, meaning we need to find our lateral area. Then, afterwards, we need to find the amount of paper and plastic needed for each container. So then we need to find the amount of plastic, which would be our base. From there, round your answer to the nearest tenth once you find out the total amount of materials needed to create these containers. So for our lateral area, we know that our formula will be lateral area is equal to pi times r times L. Meanwhile, for our base, since it's a circle, we're going to use pi r squared. Looking at our actual cone here, I'm given r is 6 and our height is 8. What are we missing? We're missing L. That's the only thing that I need. Could I say that L is equal to 8? No. 8 is the height, the altitude of the cone. L goes along the slant. So therefore, I need to find out what L is using a different method. Well, it looks like I have a right triangle, and I have two sides already, 6 and 8. Therefore, if I want to find L, I can use Pythagorean's theorem. Now this is a Pythagorean triple. This is a 6, 8, 10 triangle. Just to show you, 8 squared plus 6 squared will give me 64 plus 36, which is 100. The square root of 100 is 10. So again, this is a 6, 8, 10 triangle where 10 is my slant height. Now that I have R and L, let's go ahead and plug in. My lateral area is equal to pi times R, which is 6, times L, which is 10. Well, 6 times 10 will give me 60, so my lateral area is 60 pi centimeters squared. Next up, we'll focus in on the base. Well, the base is equal to pi r squared. Again, the radius is 6, so therefore the base is equal to pi times 6 squared, or 36 pi centimeters squared of plastic. The last thing that we need is to find the total amount of paper and plastic needed. So I'm just going to go ahead and add these together. 60 pi plus 36 pi will give me 96 pi centimeters squared of material. And if I round that to the nearest tenth, as asked, it'll give us our final answer of 301.6 centimeters squared. All right, guys, thank you so much for watching today. If you have any questions, please let me know. But other than that, have a great rest of your day.